YouTube. In my previous videos, we've been exploring quadratic equations in both vertex and in standard form. In this last video here, we're going to explore what we call intercept form of quadratic equation here. We say that this is any form f of x equals a. And I want to point something out here. This is the same a value that we use in vertex form. It's the exact same meaning. And it's the same a value that we use in ax squared plus bx plus c form, or in standard form. But we say that it's a times these two parenthetical quantities, x minus p and x minus q, where a is not allowed to be 0. But the interesting thing about intercept form is it actually tells us the x-intercepts of our parabola. And the nice thing about that is, we'll just go ahead and take a look at this picture right here. Let us say that I know what the two intercepts on the x-axis are for my parabola are. If I knew what those two values are, and in this case I'm gonna come back to this, why they are what they are, but we say that they are p and q, literally the same p and q's that you see up here in the equation. But if I knew what those were, then we could say, well, just because of symmetry, I know that the axis of symmetry must run directly between those two things. Or in other words, what you see right here, it says x equals p plus q over 2, or it's the average x value between those two there, or their midpoint of those two x values, okay? So basically, p and q, when we plug in, say, p for x, I want you to notice something here. If we were to find f of p, then we would get f of p equals a times p minus q. And it's not so much the p minus q that worries me when you plug in p, but if you were to plug in a p right here, you would get a y value of 0 because p minus p is 0, and 0 times any of this other stuff is going to cause it to be 0. And likewise, if you plug q into this equation, q minus q in this parenthetical quantity is going to be a 0, and 0 times all of this other stuff comes out to be a y value of 0. So that is why, if it's written in this form, then p and q happen to be the x-intercepts of this graph. And I want to point something out here. Because these are subtraction signs here, we say p and q appear backwards. Just like when we graph things in vertex form, we say h looks backwards, but it's because of that negative right there, that subtraction relation. And we say p and q look backwards. But because we know p and q, then we know that the axis of symmetry is halfway between p0 and q0, so the axis of symmetry is x equals p plus q over 2, or the average of those two x values right there. And then we would just say this: the parabola opens up when a is positive and opens down when a is negative. So using all of this right here, which is really not a whole lot, we just need to know that p and q tell us what the intercepts are. And let's start over here. It says graph a quadratic in intercept form when the quadratic is given by f of x equals negative 1/3, x minus 4x plus 2. And we want to label the x-intercepts vertex and axis of symmetry. So let's start with this. If we want to find the x-intercepts, I need to add a line here. X-intercepts, okay? Then what I would basically point out instantly here is that we have one at positive 4, 0, and negative 2, 0. And if you don't believe me, plug in a positive 4 right here for x, and for this one here, but plug it in, you get 4 minus 4 is 0. And likewise, when you plug in a negative 2 for this x, you get negative 2 plus a positive 2 is 0, and everything collapses to 0. So these 2 points, instantly we know are on our graph. And I would say that if you're confused as to how to use that information, just go put those on your graph right now, because I'll tell you what, if you already know that this point is on your graph, and that this point is on your graph 4, 0, then what we could basically tell just visually is that the axis of symmetry has to be this vertical line that is halfway between those 2 points. So just by observation alone, I could say, well, then x equals 1 is the equation of our axis of symmetry, x equals 1. So the thing that I will do, however, is this. We notice that the p and q values here, we should write down a, p, and q. But our p and q values are 4 and negative 2. And I observe that our a value is negative 1/3. So this is going to open downward and be a little bit wider than the parent function. But essentially, if I wanted to find the axis of symmetry, we're saying over here that the axis of symmetry is the sum of p and q divided in half. So I'd say 4 plus a negative 2. I would get 2 over 2, which is 1. So I notice that it has to be at 1 here. So now the question becomes, well, where's our vertex? Well, using what we've already discovered about parabolas, we notice it's got to have the same x value as our axis of symmetry. So it's at 1 comma f of 1. So we need to go plug in 1 into our function here. So we say, well, what is f of 1? Well, I get negative 1/3 times blank minus 4 times blank plus 2. We'll plug in our 1 and 1. So I'd get this, negative 1/3 times 1 minus 4 is a negative 3, and then 1 plus 2 is a positive 3. So So we would get negative times a negative is a positive, and anything times its reciprocal is 1. So a third times 3 is 1. We get 1 times 3 is 3. So our vertex value is at 1, 3. I'm going to go over 1, up 3. We say, well, here's our vertex. So the nice thing about this is, we can say 1, 3, is we know that it opens downward just because our a value is negative. And it actually goes down a third and a right 1, since we're vertically shrunken just a little bit, down a third, left 1. But we can actually see that it also goes through these two x values. So we can get a really accurate sketch of this parabola here on both the left and right. Oh, it's really kind of hard to draw on the right side. There we go, much better. But we say here's the graph of our parabola here. So as far as the y-intercept is concerned, well, we could find this by plugging in 0 for x is one way to do it. So we'd have negative 1/3 times, now I want to point this out, 0 minus 4 just gives us a negative 4 here. And if I were to say 0 plus 2 here, we get a positive 2. So I'm going to do this a little bit backwards. I'm going to say negative 1/3 times the product of negative 2 and, or sorry, negative 4 and positive 2, which is negative 8. And positive times a positive is a positive, or sorry, negative times a negative is a positive, but we get 8/3 here. So this point right there is 0, 8/3. But that makes reasonable sense because 9/3 is 3, and we were at a height of 3 at the vertex, but we went down 1/3 from there. So 9/3 minus 1/3 is 8/3. So we say that the point 0, 8/3 is our y-intercept. The domain is all real x values. And it looks like our range here would be all y values less than this maximum value that we reached here, and the maximum value is 3. So we say y is less than or equal to the maximum value of 3. So that's intercept form.